Welcome to The Explainer. Today we are diving deep into Python's secret sauce, the code that actually lets programs think. We're talking about conditional statements and loops. These are the fundamental building blocks that allow any piece of software to make decisions and repeat tasks. Honestly, mastering these is your first real step to writing powerful, intelligent code.
So have you ever wondered how an app knows it's okay to grant you access? Or how a game knows you finally leveled up? It can feel like magic, right? But it's not. It's all about a core concept called control flow, which is really just a fancy way of saying we're giving our code the power to make decisions and choose its own adventure.
So here's our game plan for today. First, we'll cover how programs make smart choices. Then we'll get into running in circles, productively, of course. After that, we'll learn how to master those loops. And finally, we'll wrap it all up by looking at the new tools in your programming toolkit. Okay, let's get started with the absolute bedrock of decision-making in code, the if statement. This is ground zero for teaching our programs how to react intelligently to different situations. We're going to build this up step by step, kind of like climbing a ladder. We'll start with a super basic check. Then we'll move on to a two-way choice. And finally, we'll tackle situations where you've got multiple different paths your code could take. At its heart, a simple if statement just asks a true or false question. If the answer is yes, or true, as we say in Python, it runs a specific chunk of code. If the answer is no, it just skips right over it and moves on. Think of it like a one-way gate that only opens under the right condition. And here's a classic example to show you what I mean. We set a variable, age, to 20. The code then asks, is the age greater than or equal to 18? Well, since 20 is definitely bigger than 18, that condition is true. And bam, the program prints out eligible to vote. Simple as that. But what happens if the answer to our question is no? That's where if-else comes into play. It gives you a fork in the road. If the condition is true, you go one way. But if it's false, you've got an alternative path. No matter what, something happens. This right here shows that choice in action. The code is checking if a number is even. Now, how does it do that? That little percent sign, the modulo operator, just checks for a remainder after division. For the number 5, when you divide by 2, you get a remainder. So the is it even condition is false. The code then skips the if block and jumps straight to the else block, correctly printing odd. Okay, but what if you have more than just two possibilities? For that, we need more rungs on our decision ladder. We use the if, elif, else structure. It lets us check a whole series of conditions, one after the other, until it finally finds one that's true. Now check out how smart this is. Let's say we have a score of 72. First, the code asks, is the score 90 or above? Nope. So it moves to the next rung, the elif. Is it 75 or above? Still no. Since it's run out of specific conditions, it just falls into that final else bucket and prints C or D. The really cool part is that as soon as it finds a true condition, it runs that code and then just skips the rest of the ladder entirely. It's super efficient. All right, we've taught our code how to make choices. Now let's teach it how to do things over and over and over again. We're moving on to loops, the amazing tool that lets us perform repetitive tasks without having to write the same line of code a million times. Python gives us two main ways to do this, while loops and for loops, and knowing which one to use is key. You use a while loop when you want to repeat something as long as a condition is true, but you have no idea how many times that will be. You use a for loop when you have a specific set of items, like a list of names or a string of text, and you want to do something to each one. So think of a while loop like a persistent bouncer at a club. It checks a condition. If the condition is met, it lets one person in, it runs the code, then it goes right back to the front to check the condition again. It'll keep doing this over and over until the condition is no longer true. And this is a perfect example. We start a counter I at 1. The loop says keep going as long as I is less than or equal to 5. Inside the loop, it prints the current value of I, and then, this part is absolutely critical, it increases I by 1. If you forget that I plus equals 1 line, I will always be 1, the condition will always be true, and you've just created an infinite loop. Now, the for loop is a little different. It's more like working your way through a checklist. It's designed to go through a sequence of items, one by one, and do something to each of them. And one of the most common ways we create those sequences of numbers is with a super handy function called range. This table really breaks down how useful range is. If you just give it one number, like range 5, it counts from 0 up to but not including that number. Give it two numbers, and you can set your own start and stop points. And if you add a third number, you can set a step, like counting by twos, to get all the odd numbers from 1 to 10. It's incredibly flexible. So now we can create loops, but what if we need to control them more precisely? Sometimes you need to jump in and change how a loop behaves. Think of these three keywords as your loop's control panel. Break is the big red emergency stop button. It just kills the loop instantly. Continue is the skip button. It just jumps over the current item and moves on to the next one. And pass, well, pass is a placeholder. It literally does nothing, which sounds weird, but it's really useful when you're sketching out code and need a line to fill a spot you'll come back to later. The really crucial difference to remember is between stopping and skipping. Break is like throwing the emergency brake and stopping the train completely. The ride is over. Continue, on the other hand, is like telling the conductor to just skip the very next station but keep going on the same route. The loop itself continues. All right, let's take a quick moment to recap all the powerful new tools we've just added to our programming toolkit. Seriously, this logic is what drives almost every piece of software you use every single day. We've gone all the way from making simple choices with if statements to running complex, controlled repetitions with for and while loops. This entire set of tools you see here, this is the engine that drives intelligent, dynamic programs. The logic we've just covered is the powerhouse behind everything from simple scripts that automate your boring tasks to complex AI recommendation engines. With these tools, you can tell a computer exactly how to think. So the only question left is, what will you build with that power?